Hi, my name is Fan. Today, I'll talk about my project face recognition based on video. With the rapid development of information technology, how to ensure the security of information has been widely considered by society. Compared with traditional authentic technology, biometric-based technology is more stable, convenient, and secure, and has been widely recognized by the public and widely used. In this project, we will capture the video by using OpenCV, take one frame every several frames to do face recognition, call the face detection model in Delp to detect the face and get the key points of the face by using the face key point predictor of Delp. Then use the face recognition model of Delp to compare the feature values of the obtained face with the feature values of the face in the local face library, so as to complete the face recognition. This project uses OpenCV to get the video data stream, captures the video or the image from the camera, take one frame every very few frames to do face recognition. Call the face detector in Delp to detect the face and get the key point of the face through the face key point predictor of Delp. Then use the face recognition model of Delp to convert the 68 key points obtained into 128 dimension facial descriptors. We determine whether the face is the same person by calculating the distance between the 128 dimension facial descriptors of the face and the 128 dimension facial descriptors of the face in the local face library. And when the distance is less than a specific threshold, the recognition is considered successful and labeled with the person's name. Otherwise, it is labeled with unknown. Finally, the tagged image has, as well as the video, are output to local. In this project, we use two models in Delp that have been trained to work very well: the face key point predictor and the facial recognition model. Let's first introduce the face key point predictor. Delp 68 key point detection is implemented based on CVPR 2014, one millisecond phase alignment with an ensemble of a regression trees based on the ensemble of a regression trees algorithm. It is extremely fast and works well. At the same time, it can handle the case that some key points in the training set are missing from the collaboration. Delp used the ERT algorithm to label 68 feature points, which is a regression tree-based face alignment algorithm. This method regresses the face shape from the current shape to the real shape step by step by building a cascaded residue regression tree. A residue regression amount is stored on each leaf node of each JBTD. And when the input falls on a node, the residue is added to re-input for the purpose of regression. And finally, all the residues are superimposed together to complete the face alignment. The figure on the left is the face feature point of Delp, and the point and the right is the actual method it's used. Then we introduce the facial recognition model. The face recognition model used in Delp is based on a deep residue network, which is constructed by residue blocks, and it effectively solves the gradient disappearance as well as gradient explosion problems. When the network depth is large, the error of the normal network increases, while the deep residue network has a smaller error. The face recognition here converts 68 feature key points of a face into 128-dimension facial descriptors by using a depth residue network for face recognition. The figure on the left is the 128-dimension facial descriptors made by conversion, and on the right is the actual method be used. After introducing these two models, let's start our recognition. We need 5 steps to implement our recognition. The first is local face library creation. The next is video processing, and the next is a face detection, and the next is a face recognition. And next is a save recognition video. First of all, we need to build a local face database, which is used as a reference for video recognition later. We selected 6 main characters from a very famous TV series, Friends: Chandler, Joy, Monica, Paul, Richard, and Rose as our recognition objects. We first collected 5 pictures of each of the 6 main characters as our face image data. By using the model shape predictor 68 face landmarks and the face recognition model, we can perform face detection on multiple images of the same person separately, obtain their face key points by ERT face alignment algorithm. And then the key points are converted into 128-dimension facial descriptors. So that we got 128-dimension feature values corresponding to each main character's corresponding 5 pictures with the different correspondence. After that, we average the corresponding 5 multiple 128-dimension feature vectors of each person to reduce the error. And finally, we save the average 128-dimension feature vectors of all people into a field as a face feature library field for face recognition. In this way, our local face library is created. In fact, we first use a forward face detector with DELP and load the face key point predictor with DELP shape predators to obtain the face key points. The 68 key points obtained in the previous step are transformed into 128-dimension facial vectors by using the DELP face recognition model. Then we design the code to read all the images of the face we wanted to recognize prepared in advance, and the data of different people are stored in different CSV films for averaging afterward, the purpose of which is to make the error decrease by averaging. After processing the data of each person, we calculated the mean value of each person and store the facial features of each person in the feature all field, which is used as a control variable in recognition. At this point, we have a 128-dimension facial features vector for each of the 5 people. This completes our local face database. Then we use OpenCV to process the video. We design the code to process the video by frame, intercepting 1 frame every 6 frames. After processing the video part, we design the face recognition, input the image that has passed the face check test, convert the key points of the face on the intercepted frame into 128-dimension face recognition description, and calculated the distance with the 128-dimension face descriptors in the face library. When the distance value is less than a specific threshold, the person is considered to be matched and the recognition is successful and labeled. When no one is less than that threshold, hits the unknown label. We design the code to detect each face measured in the intercept frame and extract the feature And finally, compared with the data of feature all in the local face library, if the distance is less than threshold, it means recognition is successful and labeled it. Otherwise, the recognition is failed and labeled unknown. This part is for evaluation. By running the desired code, we obtained the 128 dimension facial features descriptors for the 6-bit. This table shows only a part of the results. After the intercept calculation of the video, the model achieves the face recognition of the video and saves it. We obtain the result graph of recognition as follows. This is Monica, this is Rachel. Of course, the recognition accuracy of our desired model is not 100%. The threshold value also affects the recognition of the face in the recognition process. If the threshold value is large, there will be many successful detection, but the accuracy of recognition will be reduced. We recorded the results by varying different recognition thresholds for the images of 30 times. Through the results, we found that we achieved a high accuracy around the threshold value K of 0.55. When the threshold value is slightly larger, the number of faces that the model can detect increases. And at the same time, the difficulty of the successful recognition increases because the values of these 6 people's facial data do not differ very significantly. So the correctness of the model decreases. The local, so make a conclusion. The local face database is successfully established, which is used as a base for the accuracy of face recognition afterward. After that, the video is transformed into frame image for recognition output by recognize the intercept frames, and finally good results are achieved. This method is efficient, fast, simple, effective, and portable. Of course, the model designed for this project has some limitations. The threshold value for the face recognition will affect the accuracy of recognition, and the selection of the threshold value depends to some extent on the data of the local face database. Next, I show the code-related stuff. This is the tool model we need to use. This folder holds the images of each person that is used. This is Monica, 5 pictures. This folder holds the results of saving videos with annotation. It has a better result. This fields store the 128 dimension descriptors of each people. This is the main feature for 6 people, for all 6 characters. This is our face recognition code. The project has been completed. Thanks for your listening. Thank you.